All right. Sound recorder?
Take some video.
Oh, camera. Cool. Oh, wow. That's really neat. And so sometimes what is good is each of these, you normalize them. So what you do is you take this and you take this value, 0.01, and you divide it by the max of duration. Okay, which would be this.
0.1.
So every value in duration, it's not a duration, it's a value between 0 and 1. Then you go to F start and you do the same thing. Everything in here. Hey.
So I was just going to say 3:05 is free for this afternoon if you wanted the computer.
I think we're okay actually. We're just whiteboard's good. But thank you. Everything okay?
Yep.
Taking along?
Yep. I have a meeting from 2 to 3. Really finishes on time.
Okay.
So if it doesn't, I'm going to head out afterwards.
So I'll see you on Thursday.
But if it finishes early, I'll come back.
Can you have a look at the stuff that Novella sent through and see if you've got any preference around design? I've marked it for you. It's in my in. I think you got a copy of it anyway. And just have a look and see if you've got any preference. I'm a bit mixed about it. I like them both.
所以佢就把它当做是灵异的资料嘛，可是这样不是 no more distribution.
Yeah. Yeah. Okay, thanks. So this will scale between 0 and 1.
Why?
Why?
I'm not sure.
So all of our values for all of our measurements will scale between 0 and 1. And it actually improved because they're all in the same scale. We're not in milliseconds and kilohertz for the neural network to try and deal with all these different dimensions. They always scale between 0 and 1. Now the trick to this is if you had an unknown, you have to know what the maximum duration is. Okay, you get an unknown bat, you divide it by that, and that value goes into to find out the answer from the network. So the trick to this is your training data must have the extremes. Because if you suddenly find a bat that's got a longer call than your training data, then your value is greater than 1. And then it doesn't work. Then you get a funny result. So this was a trick an engineer taught me. And when the paper on the bats, the 2001, my results just went up when I scaled all of my values between 0 and 1. And that also helps. You remember I told you we've got that sigmoidal function that goes from 0 to 1. Part of it is that's the output, but all of our inputs are on different scales, right? But if your input scales from 0 to 1 and your output scales from 0 to 1, it's much more powerful. So this is something that we can do later because it's very easy to do. Okay. In Excel, you create a column and you say, so if you've got A1, or A, so 1, 2, 3, B, C, and you've got your data here. This one is equal to A1 divided by the max of A, right? And then you just go whoop, down, you got your new column. Done. Right? And then you do that for
data transfer, right?
Yeah, you just transfer. It's what's called normalizing. You normalize it between 0 and 1. So that's another thing we can do with the data before it goes into the neural network. And that was, when I did my postdoc doing that work, that was the biggest breakthrough that I had, was to normalize them. I'd forgotten I did it.
Okay.
So that's another thing that we can. Now, if they're all in frequency or they're all in time, it's okay. But because we're dealing with duration, frequency, entropy, all of these things, because entropy will scale between 0 and 1. We've got all of these different scales, and it makes it a very big problem for the network to deal with. It can be a lot quicker to train as well and test. So, but we can try those things once you've decided on how you want all of this.
Okay. All right.
Okay?
Okay.
Right.
Late.
Leave? Okay, I don't want to get in your way.
Okay.